So now we're going to look at something known as the autoionization of water. The autoionization of water. Right? So for example, right, if I just had a beaker containing pure water, right? What happens is that one water molecule can combine with another water molecule, okay, and these guys end up producing H3O plus and OH minus. Okay, this is known as the autoionization of water. That even in just a pure water, right? If you just had liquid water sitting there, a very small fraction of water molecules would end up ionizing. The simplified form of this equation is simply H2O ionizes to form H plus and OH minus. Again, these two equations mean the same thing, okay? Actually, H plus ions exist in aqueous solutions as hydronium ions, right? But as a simplified, just to simplify this expression here, instead of writing H2O and H3O plus, just written H plus and OH minus here. Okay, so H2O can ionize a small fraction of water molecules, a very small fraction of water molecules ionize to form H plus and OH minus ions. Now, what's the equilibrium constant for this? Right? Look at the equilibrium constant. Right? That is the concentration of H plus times the concentration of OH minus, okay, divided by the concentration of water. Right? But in this case, right, because it's pure water and a very small fraction of water molecules are ionizing, right? So for example, if I had like 1 billion molecules of water, right, maybe barely even 1,000 will actually ionize, even lesser than that. So it's a very small fraction that actually ionizes. A very small fraction of water molecules ionize. So we can say that the if for example I had some initial amount of water, right, and at equilibrium a very small fraction ionizes, we can say that the concentration of water remains unchanged. We can say that the concentration of water is a constant throughout, because such a large excess of water that even after ionizing, the amount of water molecules you had before ionizing and after ionizing is roughly the same. So we can say that this is a constant. The concentration of water is a constant. Okay, we can take this as a constant. So therefore, then we can say that Kc times the concentration of water is also a constant, and this is simply H plus times OH minus concentration, right? And because this is a constant, okay, this constant is something we call Kw, and Kw is equal to the concentration of H plus ions times the concentration of OH minus ions. Okay, this is known as the ionic product of water. This is known as the ionic product of water. We just simplified this expression because we know that the concentration of water can be assumed to be constant because there's such a large amount of water molecules and such a small fraction of them actually ionize. We can say that this concentration of water is a constant, which means that the equilibrium constant times this concentration is also a constant, and we call that constant Kw. Okay, instead of always writing concentration of water, we just get rid of that. We combine Kc and the concentration of H2O. We call this Kw. Now at 25 degrees Celsius, Kw is equal to 1 times 10 to the power of negative 14, okay, 1 times 10 to the power of negative 14 mole squared dm to the power of negative 6, right? The units for Kw are simply concentration times concentration, so that would be mole squared per dm to the power of 6. This is the value of Kw at 25 degrees Celsius. It is the value of Kw at 25 degrees Celsius, or we can say at 298 Kelvin. Obviously, if we change the temperature, we'll change the value of the equilibrium constant. In this case, actually autoionization is an endothermic process. So an increased temperature means increased ionization. Now the question is, what is the concentration of H plus ions and hydroxide ions at 25 degrees Celsius? What is the concentration of H plus ions and hydroxide ions in water at 25 degrees Celsius? So over here we can say that if at let's say 25 degrees Celsius, right, we know that the ionic product of water is 10 to the power of negative 14. That's the concentration of H plus ions times the concentration of hydroxide ions. And we know that at equilibrium, right, we have the same number of moles of H plus ions and OH minus ions. For every mole of H2O, we form 1 mole of H plus ions and 1 mole of OH minus ions. So if I had X moles of H plus ions, right, I'd have X moles of OH minus ions. And the product of that per dm cube, right? And the product of their concentrations would be 10 to the power of negative 14. So I can say over here that X is equal to 10 to the power of negative 7 moles per decimeter cube. So this is the concentration of H plus ions, and this is also the concentration of OH minus ions in pure water. Okay, in pure water at 25 degrees Celsius. Now knowing this, right, let's calculate the pH of pure water at 25 degrees Celsius. Okay, now pH is a measure of the H plus ion concentration. Okay, pH is defined as the minus log to the base 10 of the concentration of H plus ions. Okay, they is simplified to minus log because base 10 is taken as default. So in your calculators, right, if you have a log button and if you check log 10, right, log 10 should be equal to 1. If log 10 is equal to 1, that log is to the base 10. All right, so pH is simply minus log of concentration of H plus ions. Okay, that's how we define pH. Right, we define pH this way. It is simply a measure of the concentration of H plus ions, right? And a lower pH means we have a higher concentration of H plus ions, and a higher pH means a lower concentration of H plus ions. You learned this before, right? In you guys have learned this in O levels as well. Lower pH means more acidic solution, right, below, and higher pH means more alkaline solution. So the lower the pH, right, the more acidic the solution, the higher the concentration of H plus ions, right? So they're inversely related. Right? So what we can say is that lower pH means higher concentration, or the other way around, we can say that higher concentration of H plus, right, more acidic solution, the lower the pH. Okay, the lower the pH. So if we talk about pure water, right, if we talk about pure water, right, for pure water at 25 degrees Celsius, we learned that the concentration of H plus ions is 10 to the power of negative 7 moles per decimeter cube. So we know that the concentration of H plus is equal to 10 to the power of negative 7 moles per decimeter cube. And the pH is simply the minus log of H plus, and that will come out to 7. Okay, so the minus log of 10 to the power of negative 7 is equal to 7. So this is the pH of pure water at 25 degrees Celsius. Again, something that you guys have been learning since O levels, right? But this is the pH of pure water. Okay, the pH of pure water at 25 degrees Celsius, or 298 Kelvin. Similarly, of course, when we talk about pure water at 25 degrees Celsius, right, the POH, okay, the POH is equal to the minus log to the base 10 of the concentration of OH minus ions. Again, this little p here simply means the minus log of something, right? So when you say pH, it means the minus log of H plus concentration. When you say POH, the p again means minus log of the concentration of OH minus ions. And again, this is just a measure of the OH minus concentration. Higher POH means lower concentration of OH minus. So again, this is the measure of the concentration of hydroxide ions, right? Higher concentration of hydroxide ions would mean lower POH, okay? And again, for pure water at 25 degrees Celsius, right, for pure water at 25 degrees Celsius, right, the pOH is equal to, right, we know that the concentration of hydroxide ions is equal to 10 to the power of negative 7 moles per decimeter cube. So that means that for pure water, right, we can say that the pOH is equal to the minus log of the OH minus concentration, that's minus log of 10 to the power of negative 7, and that is equal to 7. So the pH is equal to the pOH, right? And this is how we define neutrality. This is how we define neutrality. We can say that because the concentration of H plus ions is equal to the concentrations of OH ions, right, is equal to the concentration of hydroxide ions, right, we can say that pure water is neutral. Okay, so now we are redefining neutrality. The word neutral doesn't mean a pH of 7. That only applies at 25 degrees Celsius. The word neutral, if I'm talking about an aqueous solution and I say that that solution is neutral, what I mean by that is the concentration of H plus ions is equal to the concentration of OH minus ions. Okay, or we can say that for that solution, the pH is equal to the pOH. Okay, this is what we mean by neutral. When we talk about the autoionization of water, right, we have again H2O ionizes to form H plus ions and OH minus ions. Okay, and this autoionization process is an endothermic process. In other words, the enthalpy change for this process is positive. Okay, so if I increase the temperature, I increase the concentration of H plus and OH minus ions. So for example, at 100 degrees Celsius, okay, at 100 degrees Celsius, we realize is that Kw, okay, at 100 degrees Celsius, Kw, which is equal to the concentration of H plus times the concentration of OH minus, is equal to 5.13 into 10 to the power of negative 13. As an example, right, we know at 25 degrees Celsius, this value is 10 to the power of negative 14. If I increase the temperature, because this is an endothermic process, if I increase the temperature, right, there's a greater degree of ionization, right, equilibrium shifts to the right, because it's an endothermic reaction. When equilibrium shifts to the right, the concentration of H plus and OH minus increase and Kw increases, right. Endothermic reaction, increased temperature, higher value for the equilibrium constant. Now the question is, what is the pH? What is the pH of pure water? What is the pH of pure water at 100 degrees Celsius? What you can say here is that the concentration of H plus and OH minus at equilibrium is the same, right? A certain amount of water is ionizing. Whatever concentration I have of H plus, I'm forming the same amount of OH minus ions, right? And their product is equal to 5.13 into 10 to the power of negative 13. Okay, so what I can say here is that, okay, I have my concentration of H plus ions is x moles per dm cube, and my concentration of OH minus ions is also x moles per dm cube, and this is equal to 5.13 into 10 to the power of negative 13. So I get x squared is equal to 5.13 into 10 to the power of negative 13, and therefore I can say that x, which is my concentration of H plus ions, right, is equal to the square root of this value, which is 7.16 into 10 to the power of negative 7 moles per decimeter cube, right? And this is obviously equal to the concentration of OH minus ions as well, right? So we can say that the pH is equal to the minus log of the concentration of H plus ions. That's how we define pH, and that is equal to 6.15. All right. So does that mean that water is not neutral at 100 degrees Celsius? Over here, right? Just because the pH is below 7 does not mean that water is not neutral. Again, over here, the pH is still equal to the pOH. In other words, The concentration of hydroxide ions is equal to the concentration of H plus ions, and that is how we define neutrality. Okay, so pure water is still neutral at 100 degrees Celsius. So just because the fact we learned previously that a pH of 7 means a neutral solution. That's no longer the case. pH of 7 means neutral at 25 degrees Celsius. Okay, at a different temperature, right, a neutral solution will have a different pH. At 100 degrees Celsius, for example, pure water has a pH of 6.15, but that's even though it's below 7, because it's equal to the pOH, or because the H plus and OH minus concentrations are equal, we can still say that water is neutral. Water is neutral. Okay, because again, these two things are true, or this thing is true. Now, similarly, right, because this autoionization is endothermic, right, you can have something at 0 degrees Celsius as well. Right? At 0 degrees Celsius, okay, Kw, which is again the concentration of H plus times the concentration of OH minus, okay, that is equal to 1.1 into 10 to the power of negative 15 mole squared per dm to the power of 6. Okay, those are the units of Kw, mole squared dm to the power of negative 6. All right. Now again the question is, what is the pH of pure water at 0 degrees Celsius? So again, a similar idea here, right? We know that the concentration of H plus will be equal to the concentration of OH minus. That, let's just call that X, right? So we can say that the concentration of OH minus is equal to the concentration of H plus, and that is equal to, right, let's say X, right, over here we said that it's X, right, and what we're saying here is that X squared, right, that is H plus times OH minus E concentration is equal to 1.1 into 10 to the power of negative 15. So X comes out to 3.316 into 10 to the power of negative 8, right? So this is your concentration of OH minus and H plus ions here, right? So we can say that the pH is the minus log of the concentration of H plus, and obviously this is equal to the pOH in this case because it's pure water, and this is equal to 7.48. Okay, so now the pH of pure water is above 7 at 0 degrees Celsius. That still doesn't mean that water is neutral. Water is still neutral because the concentration of hydroxide is equal to the concentration of H plus ions. Okay, or we can say that the pH is equal to the pOH. So this is how we define neutrality. When we talk about neutrality, right? When we say something is neutral, all that means is that the concentration of H plus ions is equal to the concentration of hydroxide ions. Okay, this is what we mean by neutral. Alternatively, of course, we can say that the pH is equal to the pOH at any temperature. As long as the H plus concentration is equal to the OH minus concentration, that solution is considered neutral. This applies to aqueous solutions, or the pH is equal to the pOH. Now, if the concentration of H plus ions is greater than the concentration of OH minus ions, that type of a solution is considered an acidic solution, right? In that case, remember, higher concentration of H plus means lower pH. So if H plus ion concentration is greater than OH minus concentration, that means that the pH is lesser than the pOH. Okay? If the H plus ion concentration is less than the OH minus concentration, in other words, there's more hydroxide ions in solution than H plus ions, that solution is considered an alkaline solution. Okay, that solution is considered an alkaline solution. In this case, right, again, if H plus is lesser, that means pH is greater than the pH is greater than the pOH. Now, at 25 degrees Celsius, okay, the product of the concentrations of H plus and OH minus ions will always be a constant. Or at any given temperature, the product of H plus ions concentration and OH minus concentrations will be a constant at a given temperature. At 25 degrees Celsius, the product of their concentrations is equal to is equal to 10 to the power of negative 14, okay, in any aqueous solution, right? The product of the concentration of H plus ions and OH minus ions is 10 to the power of negative 14 at 25 degrees Celsius. That is known as the ionic product of water. Now, how can we express this in terms of pH and pOH? Okay, we're going to do a little bit of derivation, and this involves a little bit of math. And if you don't understand the derivation, as I said, you can ignore the derivation. I will tell you exactly which equation you need to know. Okay, so we know that if we look at pure water, the concentration of H plus times the concentration of OH minus is equal to 10 to the power of negative 14. That's Kw, right? At 25 degrees Celsius. In any aqueous solution, the product of their concentrations will be 10 to the power of negative 14. Now, if we take the log or the negative log on both sides, we get minus log of the concentration of H plus times the concentration of OH minus is equal to minus log of 10 to the power of negative 14. This equation simplifies to minus log of H plus minus log of OH minus, okay, is equal to 14. Now the minus log of H plus concentration is simply the pH. The minus log of OH minus is pOH, and therefore, the sum of pH and pOH is equal to 14. Right? This is what you guys should be familiar with. Okay, pH plus pOH is equal to 14. Right? So we can say in this derivation, right, what we can say is that the pH plus the pOH is equal to 14. Okay, the pH plus the pOH is equal to 14. Right? This applies at 25 degrees Celsius. Okay, the pH plus pOH is equal to 14. Right? This 14 here is simply minus log of Kw. What I did was I took the minus log on both sides and I was able to derive this expression. So 14 over here is simply pKw. Okay, it's minus log of Kw. So what we can say is that pH plus pOH is equal to pKw. So what we can say here is that the pH plus the pOH is simply equal to what? pKw. And at 25 degrees Celsius, pKw is what? pKw is equal to 14 at 25 degrees Celsius. This is equal to 14 at 25 degrees Celsius. So in any aqueous solution, the sum of the pH and pOH will be equal to 14 at 25 degrees Celsius. Right? But the sum will always be equal to pKw. The value of pKw can vary based with depending on temperature. But at 25 degrees Celsius, Kw will have a value of 10 to the power of negative 14, which means that pKw will have a value of 14. So what we've also learned is that in any solution, the pH is the minus log of the concentration of H plus ions. Right? Now, if you were given the pH and you wanted to find the concentration of H plus ions, you can say that the concentration of H plus ions is equal to 10 to the power of negative pH. So for example, if we talk about pure water, at 25 degrees Celsius, right, the pH is 7, so the concentration of H plus is 10 to the power of negative 7. Right. Similarly, right, we know that pOH is equal to the minus log of the concentration of OH minus ions, and therefore the concentration of OH minus ions is equal to 10 to the power of negative pOH. And lastly, of course, we just learned that pKw is equal to the minus log of Kw. So we can say that Kw is equal to 10 to the power of minus pKw. So in this case, right, at 25 degrees Celsius, pKw is equal to 14, or Kw is equal to 10 to the power of negative pKw, that's 10 to the power of negative 14 at 25 degrees Celsius. So you can convert between, if you're given H plus ion concentration, you can find the pH, or you can find the H plus ion concentration if you're given the pH. The same applies for hydroxide.